So I just want to go over some extra information on the argument. So as we learned last time, complex numbers can be represented as a point. But later on you also learn that this point can also be represented as a vector. So that's why we draw the ray. But you'll learn more about representing them as vectors later on in the course. But for now, I just want to focus on the argument. So the argument is very similar to what you've done in trig with radians. So positive angles are measured from the positive x-axis to the ray. So from here to there. So positive angles go anti-clockwise, while negative angles will go clockwise. So just for example, we'll call this angle here theta. So in this case, that means the argument of this complex number would be theta. So just say if we had this vector here, that means normally if we know these coordinates, we can easily find the angle theta here. So that means that in this case, the argument of this complex number would be between the positive x-axis and the vector. So just say if this angle here was, say, 3 pi and 4. That means argz equals 3 pi and 4. But similar to trig, you can go around by 360 degrees and end up at the exact same angle. And then we could go around by another 360 degrees. So as you can see, there's an infinite number of answers. So similarly, you could also go back the other way. So you could take 3 pi and 4 minus 2 pi or minus 4 pi. So yeah, there's infinite number of answers. So that's why they defined the principal argument. So as we said last time, the principal argument was defined as the angle between negative pi and it's equal to, or it's less than and equal to pi. So between negative 180 and 180. So the reason why we don't say it's equal to the negative case is because of it's just convention. So for example, let's have a look at the complex number minus 2i plus 0. So we know if we graph that, that point would be negative 2, 0. So it'll be there. So that means the argument of this, in this case from the positive x-axis to the ray or the point, would be pi there. But you can also see that if you go clockwise and take the negative case, it's also equal to negative pi. So technically they're the exact same thing, but just by convention, we'd rather use the positive case pi rather than negative pi. So the argument of our complex number minus 2i plus 0 would be pi. Alright, so I just want to quickly go over some of the negative cases as well. So remember, for negative cases, we go clockwise from the positive x-axis. So the argument of this vector here would be this angle here. So you have to be careful. So if the vector was in the third quadrant, so similar to before, we can easily find this angle here, but that's not the argument. That's just the angle between the x-axis and that vector. So the argument is actually between the positive x-axis. So that means we have to go from here to our vector. So that's actually argz.